Hello friends, in this video let us discuss about the flow chart and the block diagram of a given MPPT charge controller. In our previous video, I have already discussed about what is MPPT charge controller, what is short circuit current and open circuit voltage, how to obtain the maximum power point. Hope you remember the points. If you don't, please go through the previous video. So let us go to the topic. So we have different approaches for the MPPT. So we have a constant voltage approach, then we have perturb and observe approach, then incremental conductance approach. So the constant voltage approach is the old method which they were used earlier and which is very simple and economically it is good. But perturb and observe is the most successful one, which balance the cost as well as balance the complexity. The incremental conductance is a very high efficient, but the problem is it requires very high hardware conditions and it is bit costly as well. So the constant voltage approach of MPPT, what they do is they know the open circuit voltage of a given solar panel. So they fix 80% of the open circuit voltage as the optimal voltage. And the charging current will be adjusted to this to obtain the 80% of the VOC. So either increase or decrease the charging current so that we will get always the 80% of the VOC. So they assume this is the maximum power point which you can get from this given solar panel, but actually that is not the case. Sometimes you may get better than the 80% value. So whatever you get from this is not actually MPP. It is a one type of approach where you get a constant voltage and you change the current, the charging current, so that you get always a certain value, fixed values. So this is for a constant voltage approach, and which is not very accurate, so that they go for perturb and observe method. So it is very simple and also it is more efficient. So what they do is they, from the short circuit condition, they increase the load slowly, and when we increase the load or you increase the load condition, then the current slowly decreases and then the voltage slowly increases. So the product of these two will be taken into the account and they see what is the value of the power, and they take the next reading. Again, they compare the first reading and the second reading. If the second reading is greater than the first reading, so that means they are going in a positive side, they go for the third reading. So that means they are increase the load again, so that the voltage will increase and the current will maybe a little bit decrease. Again, the product of these two will be seen. So like this, they calculate the power for each and every load condition, and they measure the power and they compare with the previous value. So if the recent value, the current value is greater than the previous value, so again they increase the load condition. So by doing this, at one point of time, they get a maximum power, and from the maximum power, the next value will be lesser than the previous value. So that time they go back to the maximum power point and then they stop at that point. So this process is a continuous process because the lighting conditions may change or the temperature conditions may change. So because of that, this MPP point also will be keep changing. So we have to keep checking this maximum power point for a given full time period. Okay, so it is there is no fixed MPP point for a given ambient conditions. So it has to continuously do this process. So this is how perturb and observe method is working. So incremental conductance method, actually the drawback of the previous one, the perturb and observe method, is the maximum power point keep oscillating. Okay, it will oscillate so that the efficiency of this system is a bit lesser. So if you want to increase this the oscillation, or if you want to decrease the oscillation so that you want to increase the efficiency, they go for an incremental conductance method, where they see the rate of change of current with respect to rate of change of voltage. They find the slope of the power curve, and they go for a the step size. So as I told you, the values will be, the load value will be keep increasing, and one point of time they will they will stop. The incremental value is a fixed one in the perturb and observe method, but here in the incremental conductance method, so they will calculate how much distance is there from this point, what we have calculated now, from here how much difference is there. So once you calculate the difference, directly go there, and from there, if you go for the next value, you will not have any changes. So you will have the step size, different step size, so that it will not have much oscillations, and so that you will have a better efficiency than the previous method. If you see the rate of change of power with respect to voltage at zero, so that means when it is in the maximum power point, so that means there is no more changes there. So when there is no changes, so that is the maximum power point. So that means when there is no rate of change of power, so that means the tracker or the panel are working at a maximum power point. If the rate of change of power with respect to voltage is greater than zero. So that means a P1 minus P2. So or P2 minus P1, whatever it is. So if the difference between the previous value and the recent value, if it is greater, so that means we are in the incremental side. So that means it is in the left side of your curve. Okay. And in case if the value is lesser, the rate of change of power with respect to voltage is lesser than zero. So that means already you have reached the maximum power point, and you are going in the another side or a negative side. So you have to come back so that you will achieve the maximum power point. So this is a incremental conductance method. And you can see the same thing if you differentiate this dp by dv using the mathematical formula. So you can see the du v formula here. This is a differentiation formula. And when we apply that, we get v di by dv plus I. And di by dv equals to minus I by v. So this is for the maximum power point. If it is greater, it is for left side of the MPP, and if it is lesser, it will be in the right side of the MPP. So this is for the rising side, and this is for the falling side. So this is before MPP reaching MPP, and this is after reaching the MPP point. So this is a very efficient and effective method, but for achieving this, it needs a complex hardware. So it is bit costlier than the previous method. So this is a MPPT algorithm flowchart. So whatever I explained until now, so that flowchart, that concept is put in a action. So we have to see how it works. So here, let us start from here. System initialization. You need to measure the voltage and current for a given condition. Of course, we do it. We measure the voltage and current. And it is not for each sample they do the calculation. They take a 64 samples here. The 64 samples average is taken here, and that average is going to be compared here to take a further action. So first one, let us see here what happens. Panel voltage greater than battery voltage. Of course, if the panel voltage is less than battery voltage, it cannot charge the battery. So the panel voltage should be greater than battery voltage, then only there is some effect that the battery can be charged. So this is first condition, panel voltage greater than battery voltage. The second one, panel voltage less than panel Vmax. In case of any lightning or in case of any other impacts, so there could be a chance that panel voltage will be greater than, lesser than panel Vmax. Yeah, so the panel voltage should be greater than battery voltage. Okay, so that it can charge the battery. The second condition is panel voltage should be less than panel Vmax. So the panel voltage will go more than Vmax only in abnormal conditions. So we don't want any abnormal conditions. So that these two conditions, if it is satisfied, then it will go for a battery charging. So then only the panel will be connected to the battery. So once the panel is connected to battery, then you will see again conditions like this. So battery voltage less than battery Vmax. So that means if the battery is fully charged, no need of charging the battery. So if the battery voltage is less than the maximum capacity of battery, then only the charging process should be taking place. So battery voltage less than battery Vmax, this condition, and the battery charging current should not exceed the charging capacity of this particular battery. If the battery is short circuited or something like that, the battery may take a more amount of current which will spoil the system. So the battery charging current should be within the limit. So these two conditions, if it is satisfied, then it will go for a charging the battery. So before that, it will compute the MPPT. MPP point. So by adjusting this, by computing the maximum power point, by increasing the voltage or increasing the load, by adjusting that, you will be able to set the duty cycle of a buck converter. So by adjusting the buck converter duty cycle, so you can see, you will achieve the required voltage and current values, and it goes to the load management point. So from here, what happens? From here, what happens here for the load condition? So whether the load will be connected to the system or not, it depends upon battery voltage greater than battery reconnect. So this means the battery should have minimum this much of value, then only it will be connected to the load. If it is over drained, then the battery may die, or it will not work further. So we should have minimum voltage level so that it can be connected to the load. Otherwise, the battery will not be able to serve the load, and it may permanently damage the battery. So we have to check this condition for enabling the load. If this condition satisfied, the load will be enabled. If it is not, if the battery voltage is less than the required voltage or a cutoff voltage, then what happens? It won't enable the load will be disabled. So this is one important process taking place here. In the other hand, when we have battery current is less than minimum current. So if the battery the charging current, you need a minimum amount of current which is required for charging the battery. Okay, it is less than, the battery current is less than the minimum current, or when you are connecting the load, you have very less amount of current coming from the battery to the load. So in these conditions, we go for the next battery management point. So where we have a counter and we check how much time, after certain time, if it is coming back or whether it is in the same condition like that. And one more condition also is verified here: panel voltage greater than panel Vmax. This condition, if any one of these conditions satisfied, the panel will be disabled. So this means the panel will be isolated from the charge controller. So the charge controller and the remaining part will be isolated from the panel. Okay, so then also it goes to the load management. So here, until you take the reading 64 readings for making the average measurement, so there is a waiting loop also given here. So this is the MPPT algorithm. So we see here panel isolation is taking place, load isolation is taking place based upon the charging current and based upon the battery voltage availability and based upon the solar panel voltage availability and everything. So with all these conditions, so the algorithm is written or a flowchart is written. So to implement that concept, we have the block diagram here. So in the block diagram, we have also added a few more points like a temperature sensor, and we have a ambient light sensor, which we have not shown in the algorithm. Okay, so this is the solar panel which we have here to get the required voltage. And from the solar panel, we have the a MOSFET or a switch which is going to used for connecting and disconnecting the panel to the converter. So that is a charge controller. Okay, so this is what we are talking about. If the solar panel not able to give proper voltage and current readings, or if it is having very less conditions, then these cutoff condition switches will switch off so that the panel will be isolated. So if you see here the panel isolation, panel disable. So when this condition happens, so what is going to happen here? This switch is going to be off, so that the panel will be disconnected from the buck converter. Okay, so this action will be taken care by this microcontroller. This microcontroller is getting the input from various parameters like voltage sensor, current sensor, and everything. It is getting the input based on the code what we have written, so it can decide whether the panel can be connected to the buck converter or not. Okay, and also the temperature sensor and ambient light sensor, all those things are giving the input for this microcontroller. So based on these all inputs, the current amplifier gives a very important information to this charge controller. So as we seen here, the current condition, the battery current, and it should be less than Imax. So based on these all inputs, this is coming from where? From this amplifier. So how much current is coming from here to the the buck converter? It is given from here to the microcontroller, and based on that all the inputs, what happens here, this microcontroller gives the gate pulse for this two gate driver, and this two gate driver controls the duty cycle of this buck converter. We have two phase buck converter, so that means we have four switches. For each phase we have a two switches like a MOSFET or IGBTs. So these IGBTs are connected and disconnected to obtain the required duty cycle, so that to obtain the required current in the output side, so that it can achieve the maximum voltage and maximum current to get the optimal power point. So once it is achieved, then the current at the output side of the buck converter also is given feedback. So we have input side and we have output side, so we have a feedback, current feedback. So based on this current feedback, whether it is increasing or decreasing, and immediately it will multiply the voltage and current, and it will see whether the value of the previous power is greater than the existing power. It keep comparing these values. When it is reaching a point, after that it is decreasing, so that means that is a maximum power point, and it will fix the duty cycle. So in case if it is again, if the values are changing again, the process continuously taking place, so it will keep changing the duty cycle, and it will keep changing the current, charging current, so that it will obtain the maximum power point. So there is a transient voltage suppressor. So this is just before connecting the battery, so it is a voltage suppressor, and we have a 12 volt or 24 volt based upon the solar panel input here. So we will have the battery, and we also this buck converter input also will be determined by this solar panel availability. Say if you have 48 volt solar panel, maybe you will have a 24 volt charge controller, and here you will have a 24 volt battery. In case if you have 24 volt solar panel, then you will have a 12 volt charge controller, and you will have a 12 volt battery here. Right. So once this is done, then the feedback from the battery also is given voltage. What is the voltage level? Whether the voltage is full or whether the voltage is very less. So this is also again an important input for the microcontroller to take decision whether the charging process can takes place or it is already overflowing. Okay. So if the voltage is already full, then no need of charging again. So it can isolate the the charging process from the solar panel, and once the voltage is reduced, then that means again the charging can takes place. In case if you have a very less voltage, then the load can be shut off. So you can see here the load is connected through again a switch. So this also connected with the the gate driver, and we have this switch. So in case if the battery is already almost drained, so that time what happens here, the current to the load will be less, and it may not be able to drive the load. So in that case, this battery voltage will give the input to this charge controller, and the charge controller will give the signal to this gate driver to switch off this switch, so that it will turn off the load. And we have again a current sensing amplifier here. So this, it is going to see the load current. If the load is shorted, then you will have a very high current, which is not good for the battery. Or if you have very less current which is going to the load, based on that it is going to take the decision, and it is going to say whether the battery is properly discharging and the load is getting proper load current. So this current sensor and then the voltage sensor here, the voltage divider. This arrangement, these two will determine whether it will continuously connect the load or it will disconnect the load from the battery. So this is how the overall system works. And in the bottom we have two voltage regulator blocks. So one is 9 volt voltage regulator, another one is a 3.3 volt regulator. So the 3.3 voltage regulator, which is given for this current sensing amplifier and all those things, and 9 volt regulator, which is wherever we need for the other different blocks, we are using this 9 volt block as well. And the status and alarm, and we have here a status and alarm. So if you have the panel disconnect or the panel connect or load disconnect or load disconnected or the battery full, these conditions will be shown in the status and alarm conditions. So this is the MPPT charge controller block diagram. Hope it is clear for you. So here we have shown the individual block of that each and every blocks. So it is a current sensing amplifier. So this is the current sensing amplifier circuit. So which is very simple. We take the measurement here. You can see the probes here. So these probes are connected here. So those probes are given to this, and this is going to produce the output, which is going to the microcontroller. And similarly, power supply schematics, we have a 9 volt and then we have a 3.3 volt regulators. So which is going to produce the voltage required values. Voltage measurement schematics. So we need to see the battery voltage. So this is the voltage measurement schematics which we use here in this MPPT charge controller. Um, this is the lighting sensor. So based on the light availability, ambient light. So optical sensor is given here. Then we have the opto device. So we get the signal variable, variable signal we get from this, and the ADC is going to convert the analog to digital conversion, and the I2C interface is going to connect these values to the microcontroller. So based on the voltage which is produced here, so the microcontroller is going to decide how much light is coming from the given condition. And temperature block, we have a temperature sensor. Again, we have a ADC, and the hysteresis values are given here, and we will get the output at the temperature block. So this is for the gate driver IC. So this is the gate driver IC which we are using in the this one. So this gate driver IC which is shown here for one phase. So we are going to use for two phases, and similar one setup will be used also. So based on the inputs from coming from the high low conditions, the transistor will be on and off. So based on that, the duty cycle will be controlled and the load will be obtaining the current. So this is about the block diagram and individual blocks. Uh, Most probably, I will give the another video which will explain the full circuit diagram. So which I have shown you here is a block diagram and the individual components only I have given. So I will show you how these individual components are get connected, or how the block diagram is converted into circuit diagram, how functionally it works. I will explain you in the next video. Hope it is clear for you. Thank you. Thank you for watching. So let us meet in the next video to see how the circuit works in the MPPT. Thank you.